Okay, let's get started, Mike.
Yeah, sounds good.
Cool. Hello, this is Daniel from the Blockchain Infrastructure Carbon Offset Working Group. I had the protocols team at Stakefish, and I lead special projects at F2 Pool, and been part of the Blockchain Infrastructure Carbon Offset Working Group for a while. And here we are with one of our members, Mike Roth from FungyProof. So we'll be talking a bit more about NFTs and their impact on climate, and we'll be getting into how FungyProof is interacting with the climate space with NFTs, and getting into some of the nitty gritties. But yeah, let's start with that, Mike. If you want to tell us a bit about yourself, right, where you started, what your background was in crypto, and then maybe how you got to where you are today.
Yeah, sounds good. Thanks, Daniel, for having me back on here in BICOWG. My background, I grew up in Colorado, spent a lot of time in mountains, hiking, backpacking, rock climbing. Kind of come from humble beginnings where I worked multiple restaurant jobs and had to take out student loans to get a bachelor's in computer science and aerospace engineering. And then I started my career in corporate software, actually working for Boeing, doing like some software testing. And there I felt like a super small cog in a giant machine, and realized that I'm definitely more of a startup guy. So I co-founded a web development company pretty early on. That was with one of my brothers back in 2012. I scaled a small technical team there, and we did a bunch of sort of like hospitality related web apps and mobile apps. One of them being like a Chive Charities donation platform. I don't know if people on here have heard of Chive Charities, but it's basically like a blog brand, basically. And so the donation platform was to help out underfunded causes, and it was kind of like this flash crowdfunding campaign platform. So that's where I got my background and built my skills out sort of as a technical lead and a software architect. And then after that, I moved into some technical consulting and kind of kept doing more of the same there and continuing to hone my skills on product development. And then after that, sort of what brought me into crypto, or I guess around the same time, I had scraped together a little bit of cash to build a miner in like 2012 as well. So I started dabbling in mining Bitcoin and some Litecoin, and just recognized the impact that blockchain could have on the world and got super excited about that. So in 2017, after my web development company, I started one of the first decentralized exchanges called Radar. So I was co-founder and CTO there. It was an off-chain order book decentralized exchange. And by the time I ran that for about a year and a half, and by the time I had left, I think we had done about 350 million in volume, which is pennies compared to the sushi swaps and the uni swaps of today that are doing billions daily. But at the time it was a big deal. So that was super exciting. And I guess to kind of lead into what I'm doing now, I was pretty obsessed with the concept of NFTs early on, especially around like CryptoPunks. And it actually built a really small platform called Initial Pixel Offering, which is kind of like a sandbox predecessor where you could upload images and like pick a bunch of squares and it would mint it into the blockchain. This was prior to NFTs being called NFTs. And yeah, at the time I felt like there was a lot of opportunity for transformation in digital property rights, digital and physical, and NFTs might have a huge impact on that. So yeah, between that and then, just the access to capital that had a huge impact on my life, kind of from a philosophical level, I wanted to help others get access to those same opportunities. So yeah, I'll stop there. I think leading into specifically what FungyProof is, maybe give you a sec, Daniel, to respond to some of that.
Yeah, that's really cool. And I definitely do remember when Radar Relay was around, because I was definitely really interested in the 0x protocol ecosystem. But yeah, I think yeah, if you want to tell us a bit about FungyProof, I think this had mainly started from your participation, at least in the green NFT hackathon that I had been judging with Art Gnome and a few others, like some of the CryptoPunks founders. Is that basically how the climate aspects of FungyProof had been integrated, or was that before? Or, yeah, I guess tell us a bit about how FungyProof had started, as well as what when the climate positivity or the climate integrations happened.
Yeah, definitely. So there's a little bit of a background to that, and you're right that most of it was around the NFT Green Hackathon. That was where we got spun up. But prior to that, just I had done some advising for a project that was called conserve.org. And it was a company that actually wasn't blockchain related, but they were using, well, I helped them build this product that could automate panorama photo capture using drones of acres that they're trying to conserve. And it was like a crowdsourced conservation platform. And the reason this is applicable to FungyProof is it actually was the first realization I had that blockchain could be really helpful for tracking things like pollution and carbon output. And so that was sort of the moment that clicked for me. And then that led into NFTs in the future, because during the NFT boom, we had a bunch of friends and people reaching out to us, asking us what these were and how they were built. A lot of people really interested, obviously, in how they could make money on them. But we noticed that a lot of them were really poorly built, and also, could lead to scams or getting hacked. And so we wanted to build a product that would help with kind of the transparency and credibility of the NFT space. And a major component to that is around the carbon output of the blockchain itself, and the impact that NFTs were having kind of on the ecosystem. So that's what the impetus was for us to start digging into more about how we could mitigate the negatives of using blockchain, for a lot of these really interesting NFT concepts, and mitigate the carbon output perspective of them while still keeping the positive impact that they could have. And so we dug into the NFT Green NFT hackathon, and yeah, the rest is history.
Yeah, it was. Yeah, that was, I think, when we had first had connected. It was pretty cool seeing a sort of like that blast from the past from the 0x, and so definitely was bullish on your team doing something in this space. Cool. So yeah, that kind of explains how you went down sort of like the crypto climate rabbit hole. So I guess the next question, and you may have partially answered this a bit. What kind of significance does this sort of climate positive intention or integration with FungyProof have for you?
Yeah, so I touched on that a little bit, but I mentioned I grew up in Colorado, so spent a lot of time in the mountains, and there's obviously an aspect of wanting to protect and conserve nature, and I think that's a pretty big part of it for me. But yeah, I think really it's about dealing with this dichotomy of blockchain itself, in that it has a ton of potential to do a lot of good, and the ability to have a public immutable ledger to track all sorts of things, I think is pretty revolutionary for making a big impact in offsetting our carbon footprint and tracking pollution and things like that. But at the same time, yeah, there's this dichotomy between blockchain where when the blockchain itself has a negative impact on the environment. So for me, the significance is trying to figure out how we can mitigate that while still building these cool tools and technology that we're trying to build.
Awesome. All right, let's get into FungyProof and how it works and what it is. And after that, I think we can really get into some of these nitty gritties about what we had talked about in our general AMA before, especially around the carbon emissions that can be tracked at certain granular levels, from the block level to the smart contract level to the contracts transactions levels. But yeah, tell us, in detail, what is FungyProof, how it works, what you kind of see in the future, and then obviously the features that it has for the carbon emissions tracking and grading.
So FungyProof is inspired by the concept of collectible third-party grading services. So think PSA or Beckett. And so the goal was really to create a tool that provides transparency and credibility for the NFT space. We do that through a grading system that also incentivizes sort of our peers to build these NFTs with integrity. So that's the idea behind the product, to be more on the implementation or practical side. What that's doing is you plug in an NFT and it spits out a grade based on a bunch of different properties, such as the team, the project, the integrity of the team, the community, the project, and then the technology behind the NFT, how it's built, and obviously the energy output. So there's basically a carbon calculator included in the grade.
Can you tell us a bit about that carbon calculator? How did you do these types of measurements? And maybe this is going to be going into the granular details of carbon emissions tracking on the blockchain. But like what methodology?
So to take it back to the Green NFT Hackathon, we did some research on existing tools out there, and a lot of the members of the BICOWG group had done a lot of the work for us. So we leaned on the shoulders of giants to implement a lot of this research that had already been done. And one of the key sort of tech stacks that we're using is Offsetra, who had done a good portion of the research for us and has a small tool that could calculate the total amount of carbon emissions for like an entire contract. And we took that a step further, and we've now added quite a bit to our back end and the methodology to kind of break things down on a per method or per function basis within contracts and calculate out the total gas usage of NFT collections a little bit more granular, and also caching and storing that so that it's a little bit faster.
Awesome. Can you tell us, and I know that there are some of the, beyond some of this grading, before we get into these details, how, I guess, is the strategy that you have with, you have this grading concept, and you also have like this framing concept. Do you see this as sort of like an interaction or an engagement strategy with users who have NFTs and who are more eco-conscious? Or how do you plan to engage with people who are using NFTs? Right? Is the grading aspect also under the climate umbrella and context? Is that sort of like the Trojan horse to get people to care? Because there's obviously very, very different camps under the NFT umbrella. People who do care about the ecosystem and the environment, or artists who may not even want to engage with NFTs because of its climate impact. And then people who just are interested in NFTs to flip. But then this also offers them an option to maybe put some premium or some value on whatever NFT that they have to flip.
So I think there's a few parts to that, but in terms of like our target market and what we're going for, we have, as you mentioned, there's sort of two sides to our product. One of them is on the grading side, and the other is actually on like the renovation side, we call it. So the grading side is about making sure that the data about the NFTs is transparent and holding projects accountable for the way that they build NFTs and the communities that they're creating, and surfacing that information. And then once you know that information, the other half is to help renovate or offset any of the potential problems with NFTs that exist. And maybe problems is too strong of a word, but the way that we can do that is we've built this thing called a non-fungible enrichment, which is kind of like a new NFT standard, only you can attach the NFT to an existing NFT. And what this really is it's just a way for us to provide attestations to existing NFTs, and that can be basically anything. So one of the first use cases would be to attach carbon credits, retired carbon credits to an NFT in order to offset its carbon footprint. And another use case would be to try to back up or fix any broken links to metadata or images that are in NFTs. And we can do that by backing up the existing image and metadata and putting it on chain and storing it into decentralized storage. But yeah, so those are kind of two of the first use cases for NFT renovation that we're focused on. I think hopefully that answered your question.
Oh, that's really interesting. Yeah, so you're basically allowing people to kind of see, right? A lot of people who are in the NFT space may not necessarily know, maybe if they haven't deployed their own contracts that can mint their own NFTs, they might not know if they've deployed and minted their NFTs through a shared contract, if they've bought their NFTs from a particular NFT project that uses a variety of different storage mechanisms, maybe centralized storage or decentralized storage. And so regardless of all that, right, because we have some concepts of immutability in crypto, you also allow people to see and then also upgrade, which is quite interesting. And one of those upgrades is also around offsetting your footprint and then doing that calculation. Are there specific I guess climate crypto projects that you have been quite closely tracking, and how they may be able to fit into this into FungyProof's plan of offsetting and then making people aware of some of the climate impacts? And what I mean by that is there, like, how do you kind of see FungyProof and its climate integrations or fitting into this sort of composability stack that we have of, like, these green money Legos that we have now today?
Yeah, so I think everyone in the refi ecosystem has the same goal, and the goal is to mitigate the impact that the blockchain has on the environment. And we're just one of the pieces that we might be able to fit in. And I think recently one of the groups that we've been working with closely is Klima Infinity. So I've had some conversations with Timmy there around how we might be able to provide an API for a carbon calculator that plugs into their dashboard. So we can plug into the ecosystem by offering data analytics and sort of an API tool that other platforms would be able to make use of in order to calculate the carbon footprint of different NFTs and NFT collections. And then the other is the non-fungible enrichments that I mentioned. We can use different platforms like Klima Infinity or Klima DAO to basically lock up carbon credits into these enrichments, into these cases. And that offers a sort of a collaboration between those two projects in order to offset the carbon footprint of NFT collections. And they're doing something similar, but we want as many approaches as possible, just to ensure that all the different varieties of ways that you could accomplish this. And a lot of people have different preferences. Some people like the idea of our cases and think they just look interesting, and it might be a unique way to accomplish it. And then there's other ways of doing it, like wrapping an NFT as opposed to attaching something to have like an interest-bearing asset. But yeah, I'm going down a rabbit hole here a little bit. But yeah, all that to say, there's a lot of different variety in the space, different ways that we can accomplish the same goal. So we're hoping to be, as collaborative and supportive as we can to accomplish the same mission.
Oh, that's really interesting. So can you get a bit more into the API that you're going to provide for, I guess it's going to be for querying both carbon emissions that are associated with NFTs that people can kind of input when they interact with FungyProof, and then that is being displayed on a dashboard, or fed into a dashboard like Klima Infinity, or yeah, can you go a bit into that?
Yep. Yeah, exactly. So we have our own small dashboard. I guess to start at the beginning, you would just plug in an NFT, a collection address, and well, you could do it at a collection level or an NFT level, but I'll start at the collection level. So you would plug in a collection address, and it would pull up the total amount of gas used by that collection, which correlates to the energy consumption of that collection. And then we calculate using Offsetra's coefficient. Basically, we calculate the kg CO2 equivalent for that collection. And the API that we have just surfaces that information. So you would pass in an address and it would return the information about that collection. And the reason the API is helpful for this is because it actually changes over time as you have more transfers, or you execute different methods or functions against the contract. You actually change the carbon footprint of that contract. So it's an ever evolving metric.
Oh, interesting. So as an example, right, if you have, basically you can get at the individual level and then your entire collection level. So this may be perhaps coming from two different perspectives, right? One perspective is the individual holder of an NFT, and the other perspective is the person who has created an NFT, an NFT collection, right? Let's say, for example, like Yuga Labs and Bored Apes Yacht Club, when they've minted their, you know, many Bored Apes Yacht Club NFTs, they can kind of go plug in and see what their carbon footprint is for that. And then also as a Bored Apes Yacht Club holder, NFT holder, you can also see your individual, and also as what your family, I guess your family or the collection that your NFT belongs to, what its carbon emissions is. Is that correct?
Yep, exactly. So, say Bored Apes goes and offsets their entire collection using this API to calculate how much their total footprint was. They can, purchase carbon offsets for their entire collection, and that works for their entire community. But as an individual, I could also go and decide, well, I still want to be even more carbon negative, for example. So I could add more carbon credits to an individual token. But the other benefit of that is I could also, offset my entire personal collection. So if I have NFTs across a bunch of different projects, I could decide to, purchase carbon credits for my personal portfolio as opposed to at a collection level.
Oh, got it. So then the term collection can both is on FungyProof is the term collection specifically a sort of packaging or a list of NFTs that you have in a particular wallet that is considered a collection that can be measured for its carbon emissions and then offset? Or is this also like at the smart contract level where, right, there's like a 10,011.55s that are minted at Genesis when a smart contract deployed, and that is considered a collection?
Yeah, I may have misused that term. I think the latter would be considered a collection. So a collection of NFTs is really the one smart contract and the 10,000 associated with that smart contract. I think at the individual level, it's more of like, I think the term we would use is your portfolio, which would be all the NFTs that you own in your wallet.
Got it. So then maybe there's three of them, right? I guess as how they interact with FungyProof. There's the individual NFT that can be graded by FungyProof. You can measure its carbon emissions, and then you have the option to offset, right, with like the additional features, the enrichments. Then you also have at the smart contract level, there's the ability to basically plug in, I guess, the smart contract address of a 10,000 like PFP NFT project, and then you can measure the carbon emissions of that. And then there's also the portfolio level where if you've like I guess you're connecting your a wallet to FungyProof, and then you can I'm assuming customize a particular collection, or just every single NFT in that wallet, and then you can do that measurement, the carbon emissions measurement. Is that correct?
Yep.
Cool. So then for myself, right, as a NFT collector, if I had a portfolio, right, let's say I have like, 100 different NFTs that I'd purchased with my with one address, right, one account on Ethereum. There's definitely a lot of NFTs that I own that I purposefully bought, but there's also NFTs that may have been sent to me that I don't particularly want, or don't also want having considered into my portfolio. Is it just like a mass portfolio carbon emissions footprint that you guys are measuring?
So the calculations can either be at a contract level, or which would include all NFTs of one contract, or they can be at an individual NFT level. We do just, the notion of a portfolio would be grouping the individual NFTs that you would want to offset. So we don't have an interface for this right now, but we do want to provide a way to select the NFTs that you would include. So like you mentioned, maybe if you don't necessarily want some airdrop NFTs that you've received or something to be included in that, then you could exclude them.
Got it. Very nice. And then from an NFT project creator, like if I created 10,000 NFTs, then would I be able to go to FungyProof? It seems like at the moment, the only way to measure my footprint when I deploy a 10,000 NFTs is that I can only do it after the fact. It would be definitely helpful though if, right, you can get like a test grading, right, before you launch, right? Is there maybe like steps where, hey, I want to mint these NFTs. I have 10,000 of them. I'm choosing to do this and this and this, but I want to make sure the grading is perfect, right? I want like A's on all. Is that possible with FungyProof now, or is it only something possible only after the fact?
It's not possible now. Our current version of the app only does post mint validation. So once it's already created, but our next iteration, we're focusing on like the pre-mint information about an NFT, and we'd be doing that through crowdsourcing information from other experts in the community that know this info. But that's super interesting. That's actually not something I personally had considered, but creating sort of like an estimate or a look ahead to try to determine what the carbon footprint of a collection would be prior to minting it. That's a really cool idea. I'm going to take note on that.
Yeah, I guess it's like kind of, you're right. Before I deploy contracts on mainnet, I test them on Rinkeby, right, or testnet, just to see. But yeah, that would definitely help someone like me if I want to be conscious of that, to do that test, or maybe like a checklist, right? A checklist of when we're going to deploy an NFT smart contract. Right, you can make sure you do this and this. I guess that's not particularly only around climate positivity, or carbon emissions tracking, but right, just in general. Cool.
Yeah, I mean, I think it's along. Sorry, interrupt you there. I think it's along the same vein of what we're working on, which is, the grade takes into account all the different factors of how the NFT is constructed and stuff. So, yeah, having like a pre-launch checklist is something that we've considered, and we have this idea that we're working on of doing like a pre-mint review. So if you're about to launch something or you're working on something, we can provide some advising or consulting, just in a manual way to make sure you're doing it right. But a tool that could go out to maybe a test net or something you already have is a really cool idea.
Cool. Now, maybe in the last 10 or so minutes, something that I really want to get into and just have on record is this concept and the nitty-gritty details around Carbon emissions, as they're broken down from the block level, the transaction level, and even the smart contract level. We had gotten into that briefly last time, but if you can basically walk us through sort of the steps of how these carbon emissions are measured, and then also how you track them from the very beginning, right? So there's obviously a lot of different points at which people can kind of take a look at and measure the carbon emissions of a particular interaction that you have on the blockchain, whether it be minting, trading, burning even. But I think that would be very helpful, because I don't think that this is talked enough about or understood deeply. And maybe it might clear up a lot of misconceptions about it, about carbon emissions on the blockchain, at least at the particular case of Ethereum. There's a lot of other blockchains that do things differently, but
Sure, yeah. So there were these guys, Thomas Edison and Nikola Tesla. Just kidding. That might be going too far back. Yeah, for the sake of this conversation, I think it probably makes sense to focus specifically on Ethereum and EVM-based blockchains for now, just because the mechanics are the same. We can get into all sorts of different use cases when you start talking about other chains like Solana or Flow. Things are much different. But yeah, we'll focus on Ethereum. And there's sort of these top-level concepts that I think you have to understand in order to sort of follow along with how we're doing this or how we're calculating this. But so I'll go through those first. I'd say, the most important one to start is Ethereum Gas, which is basically just it's a unit of measure for the Ethereum blockchain. That's a unit of measure for performing an action within Ethereum. So every time you do something in a smart contract, or say you do a transfer, it requires a certain amount of gas in order to accomplish that. And it's a way to keep track of the total sort of usage of the blockchain that one action required. The next is there are nodes, and nodes are producing the blocks. And this is on a varying block time, but this is always happening. So blocks just keep getting produced no matter what you do. Miners and nodes are consistently producing blocks, whether or not there are transactions to fill those blocks, which we'll come back to in a second. And then on that same note, every block requires basically the same amount of energy. So you don't get any different savings on energy if the block is full or not with different transactions. If it's a completely empty block, it requires the same amount of energy. And then each block that gets produced, it has this total cap on the amount of gas that can be included in the block. So that another way to think of that is like a max number of transactions that you can fit based on how much gas they use within a single block. So with all of those pieces laid out, it's easier to understand sort of what's happening. So as blocks get produced, there is a certain amount of energy required in order to produce that block. And every time a block gets produced, it's basically the same. So what we're calculating really comes down to the efficiency of the contract itself. So if a programmer or a Solidity developer creates a smart contract and they do it in a very creative way or a very smart way, and they can make it really, really efficient, they can fit more transactions or more things into one single block, and basically accomplish more for the same amount of energy. So that's sort of the gist of how we can calculate out the difference in the energy impact on a per block and per contract and per transaction basis. To go a little bit further and talk more about kind of what specifically is in a transaction can include any interaction with the blockchain or with a smart contract. So in the case of NFTs, you have something like the mint function. The mint function produces an NFT, and that can be written, the code itself can be written in a bunch of different ways. Some people can manage to write the mint function to be more efficient, so they can mint batch mint, for example, a ton of NFTs all at once, and it uses a lot less gas than trying to mint an individual NFT 10,000 times, for example. So that's one example of some gas or energy savings. And then there's all sorts of different transactions. A transfer is also one. So if you transfer an NFT from one person to another, that's another example, and that can be written in a number of different ways. Yeah, so I think I touched on most of that. Is there anything I missed, Daniel?
Yeah, maybe as like a summary. So you're saying that, can you, or maybe not as a summary yet. So correct me if I'm wrong. There is definitely value in the efficiencies of some of these smart contracts that are developed by NFT deployers, and because it all comes down to how many transactions and how much gas is used in those transactions that all get fit into blocks, right? So it's always at the block level, and it's now there's basically always going to be a footprint, carbon emissions per block on, at least on the Ethereum blockchain. And it's just a matter of how many transactions that are meaningful to the specific NFTs that we have, that we can fit in there, right?
Yep, that's exactly right. So, yeah, I guess just to summarize a little bit further, it's just the more efficient a contract, from a programming and a gas perspective, the less energy. Well, you use the same amount of energy, but the more you can fit into each block. So you can accomplish more within one block if you're doing it in a really efficient way. And specifically, the way we're calculating that is we're digging through the way a smart contract works, including transactions, and there are these things called traces, which is going too far, but we don't need to dig into that. But it's additional sort of more granular information about the execution of these functions. We calculate all of that stuff up in order to determine the total gas usage, categorized by the things that you're concerned about. So one single NFT and all of its transfers is one example. A full collection and all of its NFTs and all of those transfers being another example.
That's awesome. Thank you for clarifying that. I guess in the future, with the merge from Ethereum, from POW to POS, as well as some of these L2 scaling solutions as they interact with both, right, the main Ethereum mainnet and then their own scaling chains, how do you see that sort of tracking happening? Right, because there can be a mint, but then there can also be a lot of transfers that happen on an L2 or are migrated.
Yeah, so if we see things on an L2, so the way that we grade, we actually can use any EVM-based blockchain. So we can pass in, a different chain's. There's a thing called an RPC endpoint, which allows us to query this information, or we can run the nodes ourselves to obtain the data. But the difference there is really just, it basically comes down to the coefficient number that we're attaching to each unit of gas. And so when we switch over to proof of work, when the merge happens, it's a good thing for everyone. We're going to be using significantly less energy. And I think for us, in general, it does make this utility, less important because the carbon footprint is not as big of a deal, which, across the board is a good thing. But I think we have to keep in mind that up until this point in time, all of these things have already happened on a proof of work chain. So until we offset the total carbon footprint of everything up to date, we haven't accomplished our goal. So we'll have a combination of basically setting a block number where we start switching over to a different coefficient or calculation of the total carbon footprint. And anything that had occurred prior to that, we can still use the original carbon footprint sort of coefficient to calculate what it was.
Awesome. Thanks so much, Mike. I think we're almost, we have like a minute left, but yeah, is there anything that you want to to say about FungyProof, the future direction it has, sort of what you're excited about for FungyProof in the climate ecosystem and measurements and offsets?
Yeah, definitely. So I think there's two things that we didn't really touch on, and they're things that we're excited about for the future. And one of those is actually, you can think about what we've created as more of like an indexing engine, and it actually enables the ability to search NFTs based on different metadata and properties that are in those NFTs. So in addition to calculating, carbon footprint, for example, we can also provide an API that lets people search for very specific types of NFTs. So an example of that is you could find all NFTs that may or may not be actually representing carbon credits themselves. So you could search for properties associated to, like, let's say an NFT is backed by a farm project. You could actually query for that, and it would provide transparency in the way what the NFTs are actually representing. And so that's a really interesting use case for the future for us. And then to take that almost a step further, we believe in the future that NFTs will probably be the backbone basically of the global economy. And so there are a lot of NFTs that actually represent physical goods, for example. So like there's a project called 4K, which is linking Rolexes to NFTs and creating like a liquid market for people to trade those Rolexes on chain, and then they hold custody and they can transfer or ship the Rolexes between parties, kind of acting as a counterparty. But what's really fascinating about this is that in the future, an NFT may actually represent something that it itself has a carbon footprint. So like there's a recent project by Alfa Romeo. They have an NFT built into the car, and they're tracking information about the car. So you could see a future where the actual carbon footprint of that car is tracked. And instead of just calculating the carbon footprint of the blockchain output, we're actually tracking the carbon footprint of the asset linked to the NFT in the future.
Very cool. Well, thank you so much for having us and joining us in this conversation, Mike.
Yeah, thanks, Dan. It's been a blast. Really appreciate it.
Okay. Bye-bye.
Bye, guys.